batch, normalization, and layer normalization. So I'll just give you the basic difference between them and exactly how it's being implemented. They are slightly complex, but you need to only understand that suppose that this is my data. Don't show it like this, probably. Suppose that this is your data. And within one batch, you show these images, batch number one, then batch number two, then batch number three, and so on. Then whenever you show, and this is your model, and within your model, you are having, layers, layer number one, layer number two, layer number three. Now layer number one, layer number two, layer number three. Then what happens is that within a batch, there is some variation that you are actually looking. Okay, some variation. You show it to your network. And your layers are outputting certain values. Better to use this thing. So your layers are outputting different values. And these values are dependent upon B1. Okay. Let us see it in a different way with some simple example that this is actually model is your students in your maybe engineering college, and this is your faculty number one. Yeah, then this is your faculty number two, then this is your faculty number three, or you can say that first year, second year, third year, and so on. Now when your batch comes in, any batch comes in, these red guys will have some value. Who these red guys? These red guys are going to have some value. Okay, and just now concentrate on these values. Don't worry about them, forget. So when B1 goes in, these values will be some, within certain range. These values will be within certain range. Why within certain range? Because B1 itself is not a single value. B1 itself is having certain amount of images. Some data, number 1, 2, 3. So they will go one by one, and for each and every dot over here, that can be seen as a data, and you are going to get these values. Then you show the second one, then you show the third one, and so on. And because of that, these outputs are varying. They will be varying. It's also okay to all. We understood this. Later I come up with the batch number 2. And this again will go in, this will go in, this will go in. Do you think, what is your say about the deviation of these values? Is it going to be remain to be exactly same the way with batch 1, or with different batches it's keep on changing? Anyone can talk.
Keep changing.
It will be changing dependent on differences in B1 and B2.
Differences between B1 and B2, differences between batches, which is completely obvious to all of us. This is also called as covariates within data. What happened? Just take it that this is my 2017 batch, this is 2018 batch, 2019 batches, and so on. And I keep on showing, these students are there, and assuming that F1 is me, I am teaching some course. And depending upon my students, my output and the grades and the marks that they are going to get is changing a lot. Then you will say that why it's changing a lot. The reason is that sometimes students are very, good. Sometimes they may be average. I'm just talking about one complete batch, not a single student, but maybe full batch. And several times it happens that, depending upon, sometimes I say, oh, that batch was very good. They were obedient. They were working very hard. Sometimes I say that, oh, they are not interested. They are more towards coding. then I say that they are interested, they are more towards research. So it depends upon batch to batch. The same thing is going to happen within the data itself. And because of that covariate shift, this is also called as covariate shift between batches. So we need to apply, so understand that this batch normalization is not applied over the weights of that layer, not over the weights of the layer. So we don't touch the weights of the layers which are there. L1, L2, L3, they are going to have different weights. I mean, whatever the weights that they want. And if you wanted to regularize over weight, then you can apply L1 or L2 type of regularization over the weights of any layer Li. That's a different thing. Sometime I must have talked about that. I forget, maybe some example I must have given, like training some student for JE or something. So the learning has to be somehow regularized. But the point here is that it's not over the weights of the layer. This new, or if I say that covariate shift is something that layer is behaving in a way, but these values are keep on changing. Sometimes it is high, sometimes it is low. And finally, I have to give A, B, C, D, and so on. These grades are not changing. So my thresholds are changing. My variance somehow need to be managed. What I need to do, I need to take this. So if I let me take, if I take image number 1 of my batch first, image number 2 of my batch 2, image number 3 of my batch 3, and all these images, then I will get the outputs of them of my different layers. So what you can do is that you take this output, you take this output, you take this output, all of them, one this single thing is nothing but this whole output. I'm just saying that's the multidimensional vector that you are getting as an output. And for each and every image, it's changing, right? And for each and every batch, it is changing. Okay. So what I do is that first I compute for each and every batch. And that is why it's called as batch normalization. For a single given batch, I find out its mu and sigma and normalize my data. So that is the outputs we are actually normalizing. We are normalizing the outputs. I get network, I get layers, I get a batch, I show that batch to my network, I get mu and sigmas, I normalize the outputs with respect to that batch, and I'm done. I mean, that is going to be the input to the upcoming layers. So that's actually batch normalization. I assume that you all understand that batch normalization is nothing but to somehow manage your gradient stable, because otherwise your gradients will be very, very big. In my previous batch, values were different. In my next batch, the values are different. The upcoming batches keep on changing this value drastically. And if these values are keep on changing drastically, your gradients are also going to be varying drastically. And if your gradients are very high, it's just like that you are driving in a hill and your speed is very fast. So several times accidents are going to happen and you may not be able to stop, and you will actually be oscillating too much. So anyways, the point is that optimizers and other things, they all are in place. But to handle the covariate shift because of the upcoming batches and their variabilities, because each upcoming batch is going to have a completely different type of cat image, completely different type of images of the same classes, and your input is also completely changing. somehow for a batch, you need to normalize and then see the next batch and again normalize. So within a batch, I am normalizing, which means that every time whenever I grade, the values are between 0 to 1 or 0 to 100 or something between something and so on. And because of that, I somehow manage the stable gradients. That's batch normalization. What is layer normalization? So when we talk about this layer normalization and somebody has said that they are difficult to normalize, the point is that if you have a network which is being unrolled like this, then you want it to, you have got a batch. Within batch, you are having multiple things. First, you show it over here. This is I1, this is I2, this is I3, I4, I5, I6. So when I1 is here, then I2 will be here. When I1 will be here, then I2 will be here, then I3 will be here. When I1 will be here, then I2 will be here, then I3 will be here, and I4 will be actually here. And this is actually T equal to 1, T equal to 2, T equal to 3, T equal to 4, and so on. So here, if I say that, how can I see a single batch? I cannot see the single batch. And then, because here the notion of batch is different. Here the notion of batch is that certain time sequence are there within something, and you cannot see each and everything over here. So what you can do at the same point of time, so what we used to do is that we take different layers, and instead of normalizing with respect to a batch, that I see that, okay, these are all my batches, and then normalize for them, we normalize for a layer. Within this layer, whatever the things that you are going to see, I normalize it after one iteration. So when you are going to just back propagate, you remember that truncated back propagation is going to happen. So back propagation happens then in the case of LSTMs and RNNs, the back propagation is happening in time. That's going to be the truncated back propagation in time. And here what is going to happen, that I just take a layer and see that whatever this guy has seen till now, it doesn't matter batch or whatever, what it actually have seen so far, and normalize it. So if you have not got the complete essence of this, believe me, it's slightly complex, but I just have given you the the essence of the thing, that when you are doing time series thing, then the notion of batch itself is actually in time. And in time, one batch is there, and then instead of doing it for a batch, you wanted to normalize it with respect to any given layer in your network. Given layer, you just see that what is the output this layer is giving continuously, and I just take all the data that's being shown to this layer and find out that what is the mu and the sigma, and normalize instead of the batch notion. And this makes it work make it work for RNN or LSTM or transformers. By the way, both of these things in Keras or wherever you are trying to code, they are single line. You like layer normalization or batch normalization, and directly it is going to work for you. With both of these things, let me formally start what we are actually looking for. And by the way, I request you to have your copy and pen, because today it's going to be a type of board work. In the morning, I was thinking to use my slides and other things. I have, by the way, very good slides, Later, if required, I may even share those things. But what I felt is that it's better to start it slowly with our with our normal board work sort of thing.
Prof,
So I
just
yes, yes,
just one question. So
yes, sir.
after normalization, how do we get back the original time series? For example, if I have, let's say, a time series which has maximum 100 or minimum 5 or whatever, after I do all this to improve accuracy and to speed it up, how do I get the original time series? Or do we
May I
care
know your
about that?
name? Yes, yes, yes.
Uh,
May I know your name?
Janamejaya, Prof. Janamejaya.
Janmay, very good question. And this means that you people are listening to me carefully. And if you are listening to me carefully, I become even more careful. But thank you very much for asking this question. I skipped one thing because I was thinking that somebody may ask this. Or if you ask, then probably I answer. Otherwise, I explain, and you may not be able to even appreciate the point. Let me write it over here. So, data is coming. I am doing normalization, mu, and sigma, and then I apply a learnable layer over here. This learnable layer is actually, trying to learn mu comma sigma. The best possible, it's the if I say the utility of this layer itself is to learn the mu and sigma, which will help or which will be the best for the previous layer. And each and every batch norm or layer norm, whatever we apply, we first do normalization. And this normalization usually take mu and sigma to, I assume, uh, 0 and 1. And then we have a learnable layer, which will learn the mu and sigma, which is best, most suitable for that layer. Otherwise, it may happen that learning different representations which are going to be in between, they are going to have a very restrictive type of representation that they need to be having a mu is equal to 0 and a sigma equal to 1. So as rightly being said by Jan Major, this last layer is actually last layer. I'm saying that batch norm layer. Batch norm is also being seen as a layer. What it is doing, this is your batch norm layer. It is doing normalization and then learning the best possible mu and sigma. So somebody will say that, sir, anyways, you have made it mu is equal to 0 and sigma equal to 1. See, even it may learn that mu equal to 0 and sigma equal to 1 if it feel that that is the best possible mu and sigma. So it depends. So here, because of this learnability, network also have got a chance to get the best possible representation. And using that layer, I assume that it is probably able to answer Janmejay's point. If not, then you can please again ask Janmejay.
Yes, sir. So, yeah, this okay. I was able to get some insight, but
Yes,
now still, I would have to scale it back, right, to get to my. Let's say I'm sort of having some generative model where I want
yes,
to check the. Let's say specific example. I'm generating synthetic data, and I have
yes.
input time series, and I do this, and I'm trying to generate synthetic time series. So in that case, I need my original data, right? So is there a descaling factor at the somewhere there should be, right?
Yes, that's true. So that's what I'm saying, that that sort of descaling is actually happening within this learnable unit. This
Okay, okay,
learnable unit, it's doing that.
okay, okay, okay. Got it, got it.
Yeah,
Yeah,
understood.
thank you.
In fact, you asked a very relevant question and helped me also to answer that in the best possible way. That's the
Okay.
rescaling. So scaling was happened and rescaling was happened, and then somebody will say that why you are scaling and why you are rescaling. It's actually, we are scaling so as to somehow manage the covariate. We are rescaling just because, as Janmay just said, that we require, sometimes the same sort of representation. Sometimes even you do not want that. So network itself is having that liberty. I hope that now it's better.
Yeah. Thank you, bro. Thank you.
Yeah, thanks. Thank you very much. Now let us, so we are there. Now, okay.